Okay, go ahead, Kate.
Okay, so on 11, we already kind of talked about it. It's the one that is like, it gives you the parabola, and then it talks about the rectangle with the base on the
Which
x-axis.
assignment is it?
4.
2.
Yeah. No, it's not. It's 2. Yeah.
Oh, it's 2.
Okay, yeah, I know the one you mean. Okay,
So you know what I'm talking about?
I do. I'm going to take over video so I can
Okay.
draw it out. I know that.
Okay. Oh, nice.
Okay, so that was the parabola. I remember that it was an upside down parabola, and I think it went 12 right there. Is that right?
How do you remember that?
Because I just did this afternoon.
Oh.
It was a 12 minus x parabola graph.
Yes.
And then we had a rectangle that was trapped under that parabola. We could go out some x value, come up some y value, and make the same on the other side. Make a rectangle, right?
Mm-hmm.
We're trying to find. What are we trying to find?
Well, we found the formula to be a equals 2x.
A for what?
Area equals 2x, and then the quantity 12 minus x squared. But I kept getting confused, and there's like several places in the homework, but I just didn't know. You have to find the domain to find the max and the min, and I don't know how to find the domain of that.
Me too.
I like the me toos. That's good. Are there any other me toos? No, just 2.
What
can x?
Colin doesn't know how to do it. I'm throwing him under the bus. I already asked him.
Yeah, that's fair. I thought I had like an idea, but I don't really know.
Okay, so domain is the values that x can be in the function, but more important in the situation. X is the distance that we're going out from the origin. So it's really how far out from the origin are we allowed to go, with the requirement that the rectangle has to stay under the parabola. Good. So when I looked at this before with Peter, we're drawing a couple of examples of possibilities. So just really quickly, we could have a parabola where we don't go very far out with x. We just go just a little ways, and then we come up, and we get a nice tall rectangle like that. Or we could go out further. We might go out here and get a shorter rectangle, but wider. Or we could go out really far and get a really tight but a really long rectangle. Does that make sense?
Mm-hmm.
But how far, we're restrained by how far we go with this parabola, because if we go beyond that intercept right there, then we're not inside the parabola anymore. So really your domain question is, what's this value right here? That's the farthest out you could go.
Okay.
Do you have an idea of how to get that?
No.
Any ideas? Anyone? Peter, chime in. Peter, leave.
Huh?
Chime in.
Oh, I couldn't hear you guys.
Oh, sorry.
Hi.
Can you hear us
It's
now?
kind of cutting out a little bit.
Oh, okay.
It's cutting out a little bit. I hear you now.
Okay, so can you give us an idea of how to figure out what this value is?
For the question mark,
Yeah.
2 to the radical 3, or on your answer sheet was radical 12.
How did you get that earlier? How did you figure it out?
I took the first equation, which was the y equals 12 minus x squared, and I just equaled that to 0. And so I did it different than what Ms. Pryor did, but I used the what's that one called, Ms. Pryor? The b, negative b plus or minus the square root.
Quadratic formula.
Yeah, I used that one. And at the end, you're gonna get 2 radical 3. But mine's kind of longer.
Does everybody see why this equation helps us get that value?
Mm-hmm.
Anyone?
Oh, because it has to be where y is 0. That value is at y equals 0.
Parabola. Peter called it earlier. He called it find the zeros of the parabola, which was right there. So to solve that quick and slick, I would just add the x squared over and then take a square root. It's a plus or minus. So the positive square root is that value and the negative square root. So the domain is, and x could be it could be 0, or we could go clear out to the square root of 12. So that's the domain, and I would say those are your x values that are possible.
So it can't go into that negative part,
It could,
like, because
like back this way.
Yeah.
Is
What
that
about
you-
before 0? Yeah.
Yeah, x could go this way, but it's the same x if we go forward as if we go backward. So if we come back here for our x value, then it's still the same x value as this one. I don't know how to.
So why is it not like negative square root of 12 to positive? You know what I mean? Like, why does it not start at the left end?
You could consider that to be your domain, and actually we did earlier today, but we ended up with a weird number because we got a negative area when we actually calculated it. And that's because this, if we used a negative x, then multiplied it by a positive y, we got an area of negative, and we want area to be positive.
Okay.
So, and that was the only issue, was a negative and positive challenge that I was having with the physicalness of being an area.
Okay.
More on this problem?
What was that?
You guys need more on this problem?
Oh, for part C of it, it asks what is the largest area the rectangle can have and what are its dimensions, and I don't know how to find that.
Okay, so let me translate that into a different question. When it says largest area possible, let me call that maximum area. And that's what we've been working with on this assignment, was finding maximums, absolute maximums, absolute minimum. So I would start by listing candidates and the candidates test. And I would include candidates of these endpoints of that interval. which is why you were asked for the domain, because that gives you some endpoints. And then where else do we get candidates besides endpoints?
Zeros and undefined.
Yeah, zeros and undefined of what function?
The derivative
Of the
equation.
derivative, right, exactly. You need to find the derivative of this. Find where a prime is 0 and where a prime is undefined. And add those two.
Oh, okay. All right, that makes sense.
If you find where a prime is undefined, would you just treat that as one of the candidates?
It's always a candidate.
Okay. So that's the same as on the assignment that we were working on today. We had to find like different candidates or were we just finding where the derivative equals 0?
I don't know if it's the same. I'm not sure what question you're asking for sure, but it's finding the work we did with today's assignments was focused on local maxes and mins. This one is about absolute maxes and mins. So you do a different test for those. For absolute, you do the candidates test. You just make your list of critical numbers and endpoints and plug them into the function you're trying to maximize. So you'd be plugging in into the, let me write that down, into the area function, and then just figure out which one's the biggest. But today we were doing local mins and maxes based off the first derivative test, looking at the signs of the first derivative and seeing if they are changing from positive to negative or negative to positive. So it's two different tests. I'm not sure what your question.
For the first derivative test, we don't have to find where x is undefined.
Oh, you absolutely do. Yes, you do. Those are critical numbers. So for both tests, you find critical numbers. This is the same for both tests, yes.
Okay.
It's what you do with them after that that's a little different.
Okay.
Sandra, is your audio working now? I'm going to take that as a no. I can see his video working now. Okay, are we ready for another question, or do we have more on this one?
I'm good.
Yeah.
Let's go to another one.
I have a extended question about what to do with the infinities or the when the critical number equals infinity.
Okay, tell me more. The critical number equals infinity?
Or I don't know how to word it.
Okay, go ahead. Just what's your question on? Tell us assignment first.
I think it's assignment 4, question 33. Yeah.
What are you looking at?
I found it already gives you what the f prime we had critical numbers.
Aspen?
So I found two numbers.
Aspen?
Hmm?
I don't know if so. If
Do you want to know the
Colleen's
equation?
Holly, are you eating? Because I can't hear Aspen over whatever crunching is happening.
I am not eating.
Collie.
Yeah, she is.
Okay, I'm going to mute everybody for a minute while Aspen tells me the question so I can just hear her.
You want me to say the equation?
Do you want me to say the equation?
I do. Tell me what you're looking at.
F prime of x equals a fraction. On the top, it's x. On the bottom, it's x minus 2.
Did I hear the top right?
X.
Say it again.
X plus 1.
X plus 1. So is that it?
I found the zeros, so or the critical numbers, where the top equals 0 and where the bottom equals 0. To find where the function equals 0 or when the function is undefined.
Okay.
And so I got negative 1, x equals negative 1 for the top, and x equals 2 on the bottom. But that x equals 2 doesn't make that derivative function a 0. It makes it into defined.
Undefined, uh-huh.
I didn't know what to do with that.
Okay. And what is this question asking for? Are we supposed to tell when f is increasing and decreasing and that stuff?
It wants to know when the function's increasing and the local minimums and maximum.
Okay, so f is the function you mean?
Yes.
Okay, so when is f? We want to say f is increasing and we want to give an interval, right? And f has local max at this place and minimum as well. Is that right? Okay. Okay, so your question's about this undefined part right here. All right, let me unmute everybody, so if somebody wants to chime in, they can. Welcome back all. Okay, so we're still going to go forward with our our derivative number line. And labeling your number lines. Who owes a quarter? And I'm going to put 0 here, since the derivative is 0 when x equals. I'm going to put undefined right here. Make that very clear. Okay, let's do some sign testing. If x is in the middle of this interval, like a number, Aspen, give me a number that's between -1 and 2.
0.
Substitute that into the derivative and tell me whether the derivative is positive or negative if you plug in 0.
It's negative.
And then let's just change the signs. Is there multiplicity on that too? Was that like all squared or something?
No, it's just multiplicity of 1.
Okay, so regular sign changes happen then. If you're not sure, you can plug in a number that's bigger than 2. I want to, actually. 17,704 is bigger than 2. When I plug that in here, do I get a positive or a negative?
Positive.
Positive on the top and positive on the bottom, so all positive. So that makes sense. All right, back here, the negative, if we back up, it should have been positive before. Okay, so F is doing what with signs of its derivative like this? What's happening here when the derivative is positive? What's happening to F?
It's going up.
Is increasing.
What about between here and here? Next in there.
Decreasing.
And here?
Then it increases again.
Oh, we can answer this question?
Yeah.
Increasing on the interval from -1 till we get to 2, that middle interval. Okay, and then I would say, here's the undefined part. Unless you
Wait, isn't Isn't that where it's decreasing? F is decreasing.
Yes, darn it. Let's try that again. Did it want to know decreasing and I just wrote increasing?
What? I can't.
Did it ask for F increasing or did it ask for decreasing?
Oh, just increasing.
Yeah.
All right, then. From negative infinity until we get to negative 1. Yes? And? Well, I think now I know your question, Aspen, when you said where it's undefined. Okay, so this one is from 2 up. But the question I think is, what about at 2 where the function's derivative is undefined? Does that mean that the function is undefined if the derivative is undefined?
No.
Not necessarily. This decrease increase could be like a cusp where our function is dropping, no derivative at the cusp and then increasing. That's possible. But it also could be that the function's decreasing on a vertical asymptote, and then increasing on the other side. And in that case, yeah, our function is undefined. So if the derivative is undefined, that really doesn't tell me whether or not the original function is undefined. So is there anything else in the problem that tells you that? Does it say like F is continuous or anything like that?
Doesn't look like it.
If not, then I would say open that. If F is not continuous, that would be an open bracket. And if F is continuous, it would be a closed bracket. And I would make that comment. Is this one that I gave you an answer for? Did I give you the answer to this question?
No.
Yeah.
Wait.
Oh,
I
yeah,
don't think it was. I don't think it was on there.
Okay. Well, that would be my comment. I don't know about if I would include 2 or not. I know I can include the open interval. I'm just not sure about the 2 because we don't know if F is continuous. For the same reason, does F have a local maximum anywhere?
Yeah. X equals -1
X equals -1. Right.
because of the sign change from positive to negative.
Right. Good job for giving the justification. Sign change in the derivative. Make sure you say in F prime. What about local minimum?
It doesn't have one, right?
Might or it might not.
Right.
Yeah. If F is continuous, it does. If F is not continuous, it doesn't. So this depends. It would be at X equals 2 if F is continuous. Otherwise, none if F is not continuous. That's a really good question. It should make you remember how important the statement that the function is continuous is to answer.
Okay.
Any questions about this problem? Okay, so this meeting is, I've got 40-minute time limits on them. If you guys want to, we can start another meeting and do another 20 minutes. Who's in?
Me.
All my questions are answered, but I'll watch.
I'm going to end this meeting and then I will send you a code to
Okay.